Okay, so today we're diving into something pretty fundamental to, well, I guess philosophy in general, right? We're talking about knowledge itself.
Yeah, getting right to the heart of things.
Exactly. And we're going to be exploring this thing called epistemic logic, which, to be honest, sounds a bit intimidating at
That
first.
can be, yeah.
But from what I've been reading in these Stanford Encyclopedia of Philosophy articles you sent, it seems like it's basically using logic to try to figure out, like, what it really means to know something, to believe something.
Yeah, that's a good way to put it. It's trying to bring that rigor and precision of formal systems to bear on these concepts that, can be kind of slippery when you try to think about them in everyday language.
Right, right. And you know me, I always want to make sure we're not getting bogged down in, like, overly technical stuff.
Of course, yeah.
So our mission here is to, unpack these ideas, make them clear, and also highlight why they actually matter, especially for, someone like you, a philosopher who's already deep into these kinds of questions.
Absolutely. I think for anyone who's spent time, really wrestling with these concepts of justification, truth, belief, all of that, epistemic logic
Yeah.
offers a really unique and powerful set of tools.
Totally. And you mentioned wanting to get a good grasp on this area, like
Yeah.
efficiently, but also thoroughly, and that's exactly what we're aiming for here. We're going to focus on the key insights, the core principles, and of course, those juicy debates that always seem to pop up in philosophy.
Always.
All right, so let's start with the basics. What, in a nutshell, is epistemic logic all about?
So, at its core, it's a branch of philosophical logic. And it's dedicated to analyzing in a formal way knowledge, belief, and all those related ideas. But, I mean, you could call any logical system that deals with these things epistemic logic, I suppose.
Right.
But the dominant approach today is to use what's called modal logic.
Okay, modal logic.
And this involves basically introducing special symbols, they're called operators, into our logical language. And the most common ones you'll see are K for knowledge and B for belief. And we often tack on a subscript to these operators to specify like whose knowledge or belief we're talking about.
Okay, so like if I'm Agent 2 and I know that the sky is blue, we'd write that how?
So you'd write ka and then whatever the proposition is. So the sky is blue.
Okay, so the sky is blue. Got it.
Exactly. And similarly, if you believe the sky is green, we'd write the sky is green.
All right, I'm following so far. So we're taking these everyday statements about knowing and believing and we're translating them into this formal symbolic language.
Right.
But why? Like, what does this fancy notation actually allow us to do that we couldn't do just talking normally?
Well, the key here is that this formal structure, this notation, it allows us to really rigorously explore the logical consequences of different principles that we might hold about knowledge and belief.
Okay, can you give me an example of that?
Sure. So, like, one principle that a lot of philosophers accept is that knowledge implies truth.
Right, you can't know something that's false.
Exactly. And in our formal language, we can express that as kavarfu, right, or varfi.
Okay.
And then because we have this formalized representation, we can actually investigate whether accepting this principle, this knowledge implies truth principle, actually commits us to other principles, maybe some that we didn't even realize we were committed to.
Oh, that's interesting. So it's like it helps us see the hidden connections between our ideas about knowledge.
Exactly. And another example is, this idea of positive introspection. Like, if you know something, do you know that you know it?
That's a good question.
Right. And formally, we can express that as kavarfi, right arrow, kappa kavarfi. So this formal representation allows us to dissect these intuitive ideas with much greater precision. And it might even reveal some hidden assumptions or logical connections that are, really hard to spot when you're just using everyday language.
Okay, I'm starting to see the power of this.
Yeah.
It's like we're creating this precise tool to test the consistency of our philosophical intuitions about knowledge.
Yes.
Now, I noticed that the articles you sent mentioned possible worlds and Kripke models. And to be honest, those always sound a bit, out there to me.
They can be a little abstract.
Yeah. So how do these abstract concepts actually help us understand the semantics, like the meaning of these logical systems we're talking about?
Right. So the semantics of these epistemic logics, it's often explained using this idea of possible worlds, and this is where the Kripke models come in. Think of it this way: when you're trying to figure out what might be the case, based on the information you have, you're essentially considering different ways the world could be.
Different possibilities.
Exactly, different possible worlds.
Okay.
And in this framework, Varphy's true in a specific world if and only if Varphy is true in all the possible worlds that you, as an agent, consider possible.
Okay. So, like, if I know there's a cat in the room, in all the scenarios I think are possible, there's got to be a cat.
Exactly. If, even in just one of those scenarios, there's no cat, then you don't truly know there's a cat in the room.
Oh, okay, okay. I'm starting to get it. So it's like my knowledge kind of carves out a specific region of like logical space, and the thing I know has to be true throughout that whole region.
Exactly. And a Kripke model gives us this concrete structure to work with. It's got a set of these possible worlds, a relation that tells us which worlds are considered possible from each other, and a function that tells us what's true in each world.
Okay, so it's like a map of all the possibilities and how they connect.
Right. And then the big questions for us as philosophers are like, what principles should govern this relation between the worlds, especially for knowledge,
Hmm.
and how does it connect to the relation for belief? And how can we extend these ideas to understand knowledge in groups?
Right, because it's not just about me and my little world of possibilities. It's about how my knowledge interacts with everyone else's.
Exactly. And this is where, these ideas have really taken off in fields like computer science, especially when you're trying to think about the knowledge states of, agents in distributed systems and artificial intelligence.
Fascinating. Okay, so we're starting to build a good foundation for understanding what epistemic logic is trying to do. But this whole approach, it didn't just like appear out of nowhere, right?
No, not at all.
The articles mention some historical roots.
Right. So while the modern formalization really took off in the 20th century, the roots go way, way back, like all the way back to Aristotle.
Oh, wow, Aristotle.
Yeah, so in his logical works like Sophistical Refutations and the Prior and Posterior Analytics, he actually laid some of the groundwork by, starting to explore the logic of knowledge and belief.
So he was already thinking about these things, but just not in the same, like, formal way that we do now.
Right. And then during the medieval period, you have thinkers like John Buridan, Pseudo Scotus, William of Ockham, and especially Ralph Strode, who really pushed these ideas forward. They started to explore these connections between modal logic, which is the logic of necessity and possibility, and epistemic themes. And it's really surprising how much their work resonates with contemporary discussions.
Yeah, it's like some philosophical problems just, they never really go away. They just get rephrased and refined over time.
Exactly.
Now, the article specifically highlighted Ralph Strode. What was it about his work that was so important?
So Strode, in his book Consequences, which he wrote in 1387, is credited with formulating a fully general system of propositional epistemic rules. And this was a huge achievement for its time. It was a big step toward treating epistemic logic in a more, systematic and abstract way. And then you also have the Oxford calculators in the 14th century, like William Hainsbury and Richard Kilvington, who were also deeply engaged with these concepts. And later, Italian philosophers like Paul of Venice, they continued this line of inquiry. They were thinking about these intricate relationships between, knowledge, truth, existence, all of that.
It's really amazing how these philosophical conversations can span centuries. And the articles mention some key overlaps between these medieval thinkers and modern logicians.
Yes.
What were some of those shared ideas?
Well, one of the crucial shared ideas is this really strong link between knowledge and truth. It's this intuition that, if you genuinely know something, it has to be true.
Yeah, that seems pretty fundamental.
Oh, right. And another fascinating parallel is that they were already grappling with something akin to what we now call more sentences.
More sentences. Those are the ones that are like, it's raining, but I don't believe it.
Exactly. And those seem inherently paradoxical, right? Like, how can you know something and not believe it at the same time?
Right. It's like your words contradict themselves.
Exactly. So these fundamental intuitions about knowledge and belief, they've persisted across centuries, even as the formal tools we use to analyze them have become, way more sophisticated.
It's like we're building on the foundations laid by these thinkers from long ago. So moving into the more modern era, who are some of the key figures that really helped to shape epistemic logic as we know it today?
Well, the modern emergence really took hold in the mid to late 20th century, and there were some crucial figures there, like Rudolf Carnap, Jerzy Hughes,
Yeah.
Arthur Prior, Nicholas Rescher, and G.H. von Wright. And, von Wright's 1951 paper is often considered like the the real starting point for the contemporary study of epistemic logic.
Oh, yeah.
But, the truly foundational work, the one that really shaped the field, was Jaco Hintika's book, Knowledge and Belief, which he published in 1962.
Hintika, he seems to keep coming out.
He's really a central figure. So in that book, Hintika provided this really clear and compelling framework for interpreting these epistemic concepts using possible world semantics. And that approach has pretty much been the dominant paradigm ever since.
Wow, so his work really set the stage for everything that followed.
It really did.
And the field hasn't just stayed static since then, right?
Yeah.
It's continued to evolve.
Oh, absolutely. So in the 1980s and 90s, there was this surge of interest in the logic of group knowledge. So how do we reason about what groups know collectively, as opposed to just individual knowledge?
Right, like how do we go from I know this to we know that?
Exactly. And then in the 1990s, dynamic epistemic logic emerged, and that focuses on modeling how knowledge and belief change over time. Like, how do you update your beliefs when you learn something new or when you communicate with someone else?
Oh, that's really interesting. So it's not just about static states of knowledge. It's about how knowledge is actually dynamic and changes in response to events and interactions.
Exactly. And since then, there's been this explosion of interdisciplinary work. There's a lot of cross-pollination between philosophy, computer science, economics, all using these tools to study knowledge and belief.
It's amazing how these ideas can branch out and connect to so many different areas. All right, so let's go back to this idea of knowing that, which you mentioned earlier. The article's got to distinguish it from other kinds of knowing. So what makes knowing that so special? Why has it been the main focus of so much of epistemic logic?
Well, until pretty recently, epistemic logic was primarily focused on this propositional knowledge, this knowing that some proposition is true.
Okay.
So like, I know that the earth is round, or I know that 2 + 2 = 4.
Right, those are classic examples.
Right. So this type of knowledge focuses on you as an agent having this specific attitude knowledge towards a particular piece of information. And that piece of information has to be something that can be true or false, a proposition.
Okay, so it's about like the relationship between me as a knower and a particular fact about the world.
Exactly. And the hen dog example we talked about earlier, that's a good illustration of how this works when you have incomplete information. So like Zoe's knowledge or her lack of knowledge about whether there's a dog in the yard, that directly affects what she can know about the safety of the hen.
Right, because it's not just about the fact that there's a hen, it's about all the other possibilities that might be relevant to that fact.
Exactly. And when you don't have complete information, you have to entertain all these different scenarios that could be the case. And this is where the possible worlds come in handy, right? They give us a structured way to understand how agents reason when they're faced with this kind of uncertainty.
Okay, I see how that works.
Oh,
But the articles also mentioned that knowing that isn't the only game in town.
Right.
There's also like knowing how, knowing what, knowing why.
Exactly. So in everyday language, we use know in all sorts of ways. We know how to ride a bike. We know what time it is. We know why this.
Okay, so let's dig into that a bit more. How do we actually formalize this knowing that within the modal logic framework? You mentioned the formal language earlier.
Right. So we start with a formal language, which we often denote as mathkawardi, especially if we're talking about both knowledge and belief.
Okay.
And this language builds on the familiar structure of propositional logic. So you have your basic propositional variables, which are like placeholders for statements that can be true or false.
Like KO could stand for it is raining.
Exactly. And then you have your standard logical connectives like and, or, not, if, then.
Right, the building blocks of logic.
And then the crucial additions are these modal operators, the ka for knowledge and the ba for belief. So ka-varfi is our way of saying agent A knows that varfi is true, and ba-varfi means agent A believes that varfi is true.
Okay, so it's like we're adding these new symbols to our logical toolkit to specifically represent knowledge and belief. And I think the articles even mentioned something called the Bacchus-Naur form. What was that about?
Yeah, the BNF, that's a really precise way of defining what counts as a grammatically correct formula in our formal language.
Oh, okay. So it's like the grammar rules for our logical statements about knowledge and belief.
Exactly. And within this language, we can even have these nested epistemic attitudes, right?
Oh, you mean like Alice knows that Bob knows that the meeting is at 2 p.m.
Exactly. So we could write that as K Alice, K Bob P, where E stands for the meeting is at 2 p.m. And these nested operators allow us to express and reason about, higher order knowledge and belief.
Higher order, meaning like beliefs about beliefs or knowledge about knowledge.
Exactly. It's attitudes about attitude.
Right. And we touched on those more sentences earlier. Those also seem to involve these kinds of higher order attitudes.
They do. So, like, believing that it's raining, but also believing that you don't believe it's raining, that involves this kind of, twisted self-referential structure.
Right. It's like your beliefs are pointing back at themselves in a weird way.
Exactly. And these more sentences, they're a recurring theme in epistemic logic. They often highlight potential inconsistencies or irrationality in our beliefs.
Like they show us where our intuitions about knowledge might start to break down.
Right. And another example is, the principle we talked about earlier, the Kavarfi, right, our Okavakare, the one that says, if you know something, you know that you know it.
Right, the KK principle.
That's a prime example of a higher order principle, and it's been debated a lot. It has some pretty significant philosophical implications for our understanding of introspection and the limits of self-knowledge.
Okay, I'm seeing how these layers of nested beliefs and knowledge can get really complex really quickly. It's like we're trying to capture the full complexity of how we think about what we and others know.
Exactly.
So let's get back to those fascinating yet slightly confusing possible worlds. The articles mention the partition principle and then Kripke models.
Right.
Can you help me see how those all fit together to give us a way to understand the meaning of our epistemic formulas?
Okay. So the partition principle, in a simplified sense, it basically says that any propositional attitude, whether it's knowing, believing, doubting, whatever, it divides all the possible worlds into two groups. The ones that are consistent with that attitude and the ones that aren't.
Okay, so it's like my beliefs draw a line in the sand, separating the worlds that fit with what I believe from the ones that don't.
Exactly. So for knowledge is true in a world if and only if Rorty is true in every single world that's compatible with what agent knows in that world.
Okay.
So essentially, your knowledge carves out a specific region of all the logically possible worlds. And for you to know something, it has to be true throughout that entire region.
Okay, so my knowledge defines a boundary, and the thing I know has to hold true within that boundary in all those remaining possibilities.
Exactly.
And in Kripke models, those are what give us the formal structure to represent this boundary and the worlds within it.
Exactly. So Kripke models, they've been the standard way of modeling modal logic since the 1960s, and especially for epistemic logic.
Okay.
So a Kripke model for knowledge, let's just stick with one agent for simplicity.
Okay.
It's a structure. It's represented as M, W, or V, V, where W is a set of possible worlds.
Yes.
This is this binary relation on W for agent A, and V is a valuation function that assigns truth values to the basic propositions in each world.
All right, so lots of symbols, lots of moving parts. But what's the key idea here?
The key here is the accessibility relation, the CALR.
Okay, accessibility relation.
It basically captures this idea of which worlds are epistemically possible for agent from a given world. So if you have W ra W, it means that from agent A's perspective, in world W could be the actual world. It's not ruled out by their knowledge.
Oh, okay. So it's like the arrows on a map showing you all the places you could get to from where you are.
Right. And then you have this indistinguishability interpretation of knowledge that comes into play here.
Indistinguishability.
Yeah, it's a prominent way to think about the accessibility relation, especially in fields like economics and computer science, where they're thinking about knowledge a lot.
Okay.
And the idea, which goes back to, people like Lehman and Oman, is that you know something if and only if it's true in all the worlds that you can't distinguish from the actual world based on your information.
Oh, that's interesting. So the accessibility relation is basically representing what I can and can't distinguish based on what I know.
Exactly. So if you can't tell the difference between two worlds, then one is accessible from the other.
Okay. Okay. And I think that's where that Zoe, hen, and dog example comes in. The arrows between those different scenarios, those were representing what Zoe couldn't differentiate based on what she heard, right?
Exactly. The arrows were the accessibility relation. So if there's an arrow from one world to another for Zoe, it means that in the first world, she considers the second world a live possibility. She can't rule it out based on what she knows.
Got it. So the arrows are showing us Zoe's epistemic landscape, so to speak.
Right. And to make this a coherent model of knowledge as indistinguishability, this accessibility relation should have certain logical properties.
Like reflexivity, symmetry, and transitivity.
Exactly.
Those sound familiar from other areas of logic and math.
Yeah.
But why are they important for understanding knowledge?
So reflexivity is the idea that every world is accessible from itself.
Okay.
And that's intuitively appealing because, you can't distinguish a world from itself.
Right, that makes sense.
Symmetry is the idea that if world W is accessible from world, then W is also accessible from W.
Okay, so it's like a two-way street.
Exactly. If you can't tell A from B, you also can't tell B from A. And then transitivity is the idea that if W is accessible from W and W is accessible from W, then W is accessible from W.
Okay, so if my uncertainty kind of extends across two steps, it also extends directly.
Right. And if a relation has all three of these properties, it's called an equivalence relation.
Okay.
And in this strong interpretation of knowledge as indistinguishability, the accessibility relation is often taken to be an equivalence relation.
Okay, so those properties actually have a deep connection to how we think about knowledge and indistinguishability.
They do.
And with all this machinery in place, the Kripke models and this accessibility relation, we can then actually say when a formula expressing knowledge is true in a specific model, right?
Exactly. So we say that, like, v-car varphi holds if and only if varphi is true in all the possible worlds that are accessible from W for agent A. And this gives us a really rigorous way to evaluate these claims about knowledge within our formal frameworks.
So we're not just like waving our hands anymore. We have a precise way to say, okay, in this model, in this situation, this agent does or does not know this particular thing.
Exactly.
And now that we have that foundation, we can start to explore these more general questions about the nature of knowledge itself.
Right.
Which brings us to this idea of epistemological principles. The articles emphasize that when we choose a formal representation of knowledge, we're actually taking a stance on these principles.
We are.
So how does that work in practice? Can you give me a concrete example?
Sure. So one classic example is the principle of veridicality, which we can express as ka varphi, right, or varphi.
Right, the one that says if you know something, it has to be true.
Exactly. And in the context of Kripke models, this principle holds if and only if the accessibility relation is reflexive.
So there's that connection again between a philosophical principle and a formal property of the model.
Right. And to see why, imagine if the accessibility relation wasn't reflexive.
Okay.
Then you could have a world where ka varphi is true, meaning varphi is true in all the other worlds that are accessible, but varphi is actually false in that world itself.
Oh, okay, because the world itself might not be among the worlds that are accessible from itself.
Exactly.
So reflexivity ensures that the actual world is always one of the possibilities that the agent is considering.
Right. So if ka-var is true, meaning varphi is true in all the accessible worlds, including the actual world, then varphi must be true in the actual world.
Okay, so that makes sense. So the properties of the accessibility relation actually dictate which epistemological principles our logic is going to endorse.
They do.
And this leads to those concepts of validity in a frame and the logic of a class of frames.
Exactly.
The formula is valid in a frame if it's true in every model built on that frame, no matter what.
Right. No matter how you assign truth values to the propositions or which world you pick as the actual world.
Okay, so it's like a really strong notion of truth. It has to hold true no matter what you do to the model.
Right.
And then the logic of a class of frames is just the set of all the formulas that are valid in every frame in that class.
Exactly. And this is a semantic way of defining a logic. But we can also approach it axiomatically, where we define a logic by a set of axioms and rules of inference.
Right, so it's like two different perspectives on the same thing. You can either define a logic by its models, or you can define it by its axioms.
Exactly. And a key concept here is this notion of a normal modal logic.
Normal modal logic.
So a normal modal logic includes all the theorems of standard propositional logic. It includes this axiom called the K axiom, which is cover right arrow right arrow cover right arrow kase.
Okay, so that's a bit of a mouthful.
It is, and it's closed under modus ponens and generalization.
Right, those are classic rules of inference.
Right, and the smallest normal modal logic is called K.
K.
And then by adding different axioms to K, we get a whole family of different modal logics. And each of these logics corresponds to different conceptions of knowledge.
So it's like we're building up a hierarchy of logics, each one capturing a a more refined set of epistemological principles.
Exactly.
And the articles highlighted S5 as a particularly important one.
Yes, S5 is a really big one.
So what makes S5 so special?
So S5 is the smallest normal modal logic that contains three specific axioms: the T axiom, the B axiom, and the 4 axiom.
Okay, TB4.
And there's a really crucial theorem here that links S5 to a specific kind of Kripke model.
Okay, what's the connection?
So S5 is exactly the logic of pointed Kripke models that are built on frames where the accessibility relation is an equivalence relation.
Ah, so there's that equivalence relation again, reflexive, symmetric, and transitive.
Exactly. So if our philosophical analysis leads us to think that knowledge should satisfy these principles of truthfulness, which is the T axiom, symmetry, which is the B axiom, and positive introspection, which is the 4 axiom, then we're basically committed to using an equivalence relation in our possible world semantics.
I see, it all ties together. So our philosophical intuitions about knowledge actually constrain the kinds of formal models we can use.
Right. And then there's another theorem that shows how each of these individual principles, the T, the B, and the 4, each corresponds to a specific property of the accessibility relation.
Oh, that's cool. So like the T axiom corresponds to reflexivity, the B axiom corresponds to symmetry, and the 4 axiom corresponds to transitivity.
Exactly. And this is really valuable for us as philosophers because it bridges the gap between our intuitive ideas about knowledge and the formal properties of these mathematical structures that we use to model knowledge.
Right, so it's not just about doing abstract logic, it's about connecting that logic back to our pre-theoretical understanding of what it means to know something.
Exactly. And the articles also mentioned a bunch of other normal modal logics that are weaker than S5, like T, D, S4. And each of these is characterized by its own set of axioms and corresponding relational properties. So it's like this whole spectrum of formal systems that we can choose from, depending on which epistemic principles we find most convincing.
This is really helping me to see how these logical systems are built up and how they connect to these fundamental philosophical questions about the nature of knowledge.
I'm glad to hear it.
Okay, so we've talked a lot about knowledge, but the articles then move on to consider belief.
Right.
So how does this framework handle the interplay between these two concepts, knowledge and belief, which are clearly distinct but also, closely related?
Yeah, so to formally reason about both knowledge and belief, we expand our language. We include both the ka operator and the ba operator for each agent.
Okay.
And our Kripke models have to be expanded as well. Now we need